Okay, so the UK as a hazardous environment does overlap with coasts, but let's talk through how the UK is a hazardous environment and the kind of hazards that it gets. So, we don't tend to get hazards such as volcanoes and earthquakes. We're a long way away from a plate boundary. In fact, the closest would be sort of the Italian Greek one. But we do have flooding as our major hazard risk. Now, this affects potentially 1.7 million homes and 130,000 sort of business properties across England alone, not even Wales, Scotland, Northern Ireland. Now, a lot of that is coastal. 1.5% of the population is at risk at coastal flooding, but we also have river flooding as well. Strong winds, windstorms can also wreak havoc on our infrastructure and our properties, causing damage. And our case study is the winter of 2013 to 14, which was the wettest on record, and that was a combination of river and coastal flooding for that. So we're going to start with why the UK weather does get these hazardous events, and it comes back to these air masses. Now, basically, air bubbles move over the UK from 6 different directions. And because of what they pass over, whether that being continent or ocean, and whether it's warm or cold, it picks up certain characteristics, that air bubble. So they get these different names. We've got, for example, polar maritime, which means it's coming from the poles, so it's cold, and over oceans, so it's going to be wet. So, consequently, that brings wet, cold air and wet, cold, showery weather. On the other hand, if we're coming from the southeast, we've got tropical continental. It's coming from tropical regions, so it's going to be warm. And over the continent, so it's going to not have picked up moisture. It's going to be much drier. So hot, dry air brings hot weather in summer. And so on and so on. So those are the different ones for you. And it's just the direction that the air mass, the air bubble, moves from means that it passes over different land or ocean and temperatures of those, and therefore brings different characteristics to Britain. And this all leads to high and low pressure. Now, we did this back at GCSE. High pressure is air sinking, low pressure is air rising. And these will bring different characteristics. Now, high pressure in summer is associated with like nice dry weather, potentially droughts if it hovers over us for long enough, and heat waves, which can be a hazard in itself. People have died from heat waves, such as back in 2003 across the whole of Europe. In winter, it's that sort of cold, frosty morning, very few clouds to trap that heat overnight. Might lead to fog in the mornings as well. Now, low pressure leads to our weather hazards that we're going to be studying a little bit more. In summer, this can lead to prolonged rainfall. So flooding in the summer, like we saw last year. Heavy rain, flash floods and storms, potentially even thunder and lightning with that as well. And then in winter, it's stormy, wintry conditions, frontal snowfall, heavy rain, floods associated with that. So as you can see, floods are much more associated with low pressure than they are high. And low pressure is air circulating anti-clockwise. High pressure is air circulating towards the middle clockwise. And these will bring different temperatures of air with them. So here's our low pressure. The winds are coming together and they're forced upwards, and that leads to the air cooling, condensing, rain clouds and rain. High pressure, the air is sinking downwards and away from each other. They spread out over the surface of the earth. Now, on a weather map or a weather chart, a synoptic weather chart, this is what you'd expect to see. Sometimes they're in colour, which we'll come on to in just a second. But high pressure is kind of anything above 1020. Low pressure is anything below that. So this is current, this is today. And as you can see, we've got an area of high pressure hovering over Europe, but affecting us as well. Air pressure's 1036 near us in the northeast here. And this has led to fog this morning. There's been ice on the cars. That fog's now burnt off. It's sort of mid-morning, and we've now got warmer conditions, cloudless skies. Over the course of the week, we're probably going to expect to see this low pressure moving towards us. So we're going to be getting rain probably, I don't know, Thursday, Friday later this week, as that low pressure leads to clouds moving over us. But that might mean that it warms up because it's coming from sort of further south, warmer air, and then we've got rainfall. Now I say it might be warming up, but these triangles and semicircles actually mean warm air or cold air. So this low pressure, this is called a front, this little line here, and that marks the beginning of cold air behind it. Now the way I remember this, the triangles, they're like icicles, cold air. The little semicircles, they're like the sun. This has actually often helped because we often have colour on these charts as well. So they're often red for the warm air and blue for the cold air. So this is yesterday, so you can see that high pressure's moved slightly further across. That low pressure's kind of hovering behind, bringing cold air behind it. Now these fronts are important because these can cause large differences in temperature from one side to the other. It's also where warmer air is coming into contact with colder air, for example. Now, if you've got a big difference in temperature, that's a strong front. That's going to lead to more intense, perhaps rainfall, or maybe a weak front is where there's not that big a difference in temperature and the rainfall will not be perhaps as extreme as a result of that. But a weather front is defined as a boundary between two air masses. That is what it's called. So that then is kind of a bit of our basics there about these. Occluded fronts, by the way, are where a cold front and a warm front basically catch up to one another, and that can lead to heavy rainfall as well. But all of these will then affect the potential for flooding in the UK. So, flood risk in the UK. The 1st of January 2019, 8.4% of all properties were at risk of flooding in the UK. Okay, so wind has a big impact on the potential for flooding as well. So let's have a little look at the influence of wind then. Now, within this, we have certain information that we need to sort of pick out. UK, wind is measured in knots, and it's on the Beaufort scale. Gusts are rapid variations in the speed of wind. Now, when we're looking at storms, just like with tropical storms, for example, we're looking at sort of the maintained wind speed, but you'll often hear on the weather forecast gusts referred to because they are 60% higher often than the mean speed, and this can lead to certain damage, trees coming down, branches coming down as well. Northerly winds tend to be gustier than southerly ones, so the direction of the air masses has a big influence on this as well. So, looking at these winds then, northerly winds bring cold air, makes sense. That can lead to cold, showery weather. Southwesterly wind brings the warm air. That can lead to lots of fogs and drizzle. South-southeast tend to occur in summer and they tend to be warmer, but that can lead to hot, thundery weather. Easterly winds bring the very cold air to the British Isles, such as Beast from the East and what we saw in early 2021 in January, February time. So that can have big influences on damage done and to the conditions that we see as well. Now, obviously, prediction is a key part for preparing people for this. Now, this is the government flooding website. Now, on this then, we can put in a postcode and see what risks there are at that present moment in time. And as you can see today, Flood alerts are possible if it rains a lot. No severe flood warnings. And there's one area where there is an extreme warning, which is the River Burn there. Now, if we put in our postcode, or one nearby, nothing of concern around us today, okay, in the Teesside area. So you can keep an eye on that. That's part of the sort of warnings they put out as a result of predictions. But how do we go about looking at these predictions then? Now, let's think about future flooding as well before we get into that in a little bit more detail. By the end of this century, the UK is expecting to see 10% rise in the average annual rainfall compared to what we saw from like 1985 to 2005, which is this image here. Basically, the darker blue, the more rainfall is going to happen. So you can see that global distribution linked with climate change. It's not just about the total amount though. We are much more likely, the International Panel on Climate Change says that Europe and the UK is very likely to see more heavy rainfall events. So that intense rainfall, as you know, leads to more likelihood of flooding, flashier floods. If you combine that with sea level rise, storm surges will get bigger, which is more likely to breach those coastal defences, and that links to the wind that we just talked about as well. Now, floods are very difficult to predict with any sort of likelihood and any sort of advance warning. So we do need defences to help step up, and that has to come from government. We can do this with ways of planning, not planning housing on floodplains. Areas are more likely to flood. And if there's no other option, flood-proof design standards need to be higher to cope with these more intense flood events that we're expecting to see. Insurers as well need to be part of that, sharing the risk, part of Chapter 1. We do need to improve forecasts and communications, such as that government website. They're still working on that as well. Now, the Flood Forecasting Centre works with the Environment Agency and the Met Office to try and put all of this together. So they'll look at river, surface water, tidal and coastal and groundwater flooding all combined together. So it's one national centre which supports emergency responses as well, and those flood warnings getting out to who needs to get them. They combine the weather and flooding expertise all together, which can lead to longer lead time flood forecasts, which are more accurate. And that can target the responders who would be the ones responsible for helping secure properties. It gives people more time to act as well. So that's their aim, and that's something that's been brought in to try and combine this. So that leads us on to our case study then. Now, we do have this timeline, which I'll come on to in just a second, and it does overlap with coasts. So let's have a little look at this case study then. These are the storms of 2013 to 14, that winter period. Now, it was a series of storms. It was caused by a westerly Atlantic flow dominating the weather. Basically, the water was coming, the air mass was coming off of the Atlantic, so it was incredibly wet. And we had a series of deep, very deep, low pressure systems, which I'll come on to why that's important, the pressure itself, with very little time between them. Now, what that means, and here's a synoptic link to water and carbon, is all of the pore spaces in the soils were filled up. The soil was saturated by antecedent rainfall, what had happened beforehand, which then led to flooding when further low pressure systems passed ahead. There were 12 major winter storms affecting the UK through this. And it was the stormiest period of weather the UK has seen for at least 20 years, the third wettest winter on record in England and Wales since 1766. You can pick out some facts from those two sources at the bottom there. So, beginning of December then, we had a series of storms cutting off power, cancelling trains, causing flooding, causing cliff erosion. Mid-December, more flooding in the south, hitting Christmas, flooding around there. Rainfall totals 156% of the UK average for December, 200% in some areas. That was an average though for the UK. That continued into January. It disrupted transport. We had high spring tides coming in then. Those records in terms of rainfall much higher than normal, much milder as well, much wetter but milder conditions. So air mass is coming from a different direction. And this does link to those tides, okay? So one key thing that we need to come on to here, tidal coefficient. Tidal coefficient is the difference between the high tide and the low tide. Now, the highest possible tidal coefficient is 120, and they work this out basically from the sun and the moon, how combined those are, and lots of physics things that I don't really understand. But it's worked between the sun and the moon, and they come out with a number, this tidal coefficient, the maximum being at 120. Now, going back to this then, the causes, and we're going to be focusing on the 5th of December 2013 floods, which was one of the earlier ones in this. That had a high spring tide, and the tidal coefficient was 94. So it was 7.2 meters difference between the high tide and the low tide. Quite extreme. And we also had an area of very low pressure. Now that low pressure, okay, basically causes the sea level to rise. If it's 960 millibars, which it was, that led to a 50 centimetre rise in sea level because there's less weight pushing it down. Imagine a rubber duck being pushed downwards by high pressure. Well, if you've got low pressure and you take your hand off, the rubber duck bounces back up. That's the same for the water. And we had strong northerly winds, 100 miles an hour. That killed 2 lorry drivers. They toppled over. But that leads to, just like me blowing across the top of a cup of tea, water spilling over the other side. It pushes the water onto the coast. So those 3 things combined meant that the water level hitting the coast, and because of the rain, river flooding was incredibly high. Now, flooding first overtopped defences in Stockton at 3:57, 4 p.m.-ish on the 5th of December. And the surge they measured there was 1.24, and remember the storm surge is the extra water on top of the high tide. The high tide was 2.85 metres higher than normal. So basically that means above sea level. The water was over 4 metres above sea level, what we'd expect at that particular moment in time. And the defences in Stockton and Middlesbrough couldn't cope with that at all. So let's have a look at these impacts, and we're going to split this up into local, national and international for you. So significance then, key things for us to know. 32 residential properties flooded around Port Clarence area, 20 businesses around there as well. Billingham and Seal Sands were affected. Roads were flooded and closed. A19 Portrack interchange, major sort of area for commuters, that was completely shut down. Another A19 trunk road there, A178 was actually shut for 2 months because of the severe damage done to the defences, and the A66 trunk road around Teesside Park shut as well. So fairly significant areas in terms of transport, but also flooding as well. So let's look at these then in terms of economic impacts. Now I'm trying to link this, another synoptic link, to changing places, the economic character. So I'm trying to get that in a little bit more for you. So locally then, Teesside, loss of income, who was shut due to power cuts and to the flooding, cost of repairing the infrastructure of those roads. Redcar Seafront and Hartlepool needed clean-ups as well. That cost 5 million in total. Property insurance, in areas where there had been that flooding, the insurance premiums went up by 50% that next year. That meant it very expensive for a lot of people. Regionally then, so down south they were hit as well. 177 17,000 hectares, that's rugby pitches of farming land, was flooded, unusable, destroyed crops, infrastructure damage as well. That led to a reduction in trade and services across the region. And, local economy shut down, businesses not being able to get things in as we needed to. Nationally then, rail systems down, cost 320 million in residential properties nationally. 8,300 properties flooded with an average cost of 23,000. 217 million to businesses with over 3,000 businesses affected. And also, because this was hitting that period before Christmas, 6.4 million visitor trips disrupted to Christmas markets, and that affected trade as well in that lead up to Christmas. Socially then, now in Teesside, we had to evacuate 351 homes from that Port Clarence area. They had to go to Billingham, and they had to leave their pets behind and sort of go and bunk down there. They got on with it. Not much fuss was made about that because of the character of the local Teesside people. We did have the power cuts. People were still going out and shopping, but they were not letting that stop them because of the social character. They were just shopping in the dark using their phones as torches. And then we had obviously those roads shut, stopping people from getting to work. And it did affect education as well. High Tunstall, Hartlepool, the roof of the school was ripped off. Middlesbrough College was closed for 2 days because it had affected that area as well. Cars were floating across the car park, sometimes with people inside, unable to do anything about that. Quite scary for those people trapped in that. Regionally then, more homes flooded. It destroyed their Christmas presents a lot of the time. Villages were cut off, abandoned in some cases. Railway lines severely damaged. People couldn't get around, as we've already mentioned. And nationally, we did have 7 deaths, a lot of these on the road. 993 emergency events, largely in sort of the northwest and southwest, people getting trapped and stranded. 120,000 power cuts, 1,000 flood incidents on roads, 180 million in delays. So that links to economic because of the delays and damage to transport network from that. And then politics had a big impact in this. As you can see with the 3 Ps, there's going to be a lot of overlap here. So the local council of Stockton, the MP, campaigned for extra flood funding from central government. That did happen, they got that, which we'll come on to with responses. Local authorities tasked with putting the emergency plans into action to get the safety, so those evacuation orders. That was done, fairly calmly. That looked quite good for the local political figures pushing for that. Same down in sort of Somerset and Southwest. Prince Charles even managed to criticise the Environment Agency for the flooding because they hadn't dredged the rivers. The river flooding, they hadn't basically got the big diggers and took out the sediment that's deposited from the rivers. And that means if they don't do that, it fills up so it can hold less water. So they were under severe criticism. Their argument, though, the Environment Agency, is that it's a natural process and it would cost a fortune to keep doing that. It would be a soft engineering sort of strategy. So, political people blaming the Environment Agency saying, well, the politicians haven't given enough money for that. And then nationally, direct costs to the local authorities, 58 million to get their assets back on track. It affected East Anglia, South West England the most. And by the 5th of February then, so after these series of storms, government committed an extra 100 million for flood works. Okay, and that was a COBRA meeting, where all the nations get together. And that was the pledge that came from it. That's a response, but that was kind of the impact on the politics as well, that sort of national outcry about this. So there you go. There's your facts you can take from that. A few more there for you. Let's have a little look at the responses. So, first of all, Met Office put out warnings straight away, but they're also working on improving those flood warnings, as I mentioned earlier on. They want clear systems, such as the website that I showed you, which has happened since then. using the media to inform the public, not relying on them to go to the website and look for it, getting the message to them. Now, they did do this. They did have warnings out. So a lot of people opted to work from home rather than travel, keep them safe. Use the warnings to take action. Cleared drains of leaves, got staff on standby, got sandbags out to where they were needed, so the local councils were mobilised. They cancelled train services as a result of those warning that danger to the train lines. Utility companies, trying to deal with those power cuts, not that it happened yet, but anticipating them and lines coming down, got staff on call for that. And then trying to improve our technological fix to improve these forecasts as a result of it. So like I said, it did manage to get people to change their actions. Not the technological fix here, but altering people's actions as a result of that. Structural fix, that's called. And then the response by the community, okay? Now, we talked about the government spending money, but the Environment Agency used a lot of their budget, 270 million repairing and maintaining defences. Local authorities had to pay for those highway repairs. Funding was given to the insurance groups, basically, to produce a film on how to protect your own homes. So getting people to take more responsibility for keeping themselves safe. We had to set up temporary housing accommodation for over 2,000 people who'd lost their homes during this, whilst they were getting cleared up. And we had business rate relief, sort of a tax that people pay. That was available. They didn't have to pay them for 3 months after the floods if their businesses had been hit during that cleanup process. Now, the Somerset area had been hit really hard by this. So, as a result of this, they did start dredging. They had pumping sites to get the water away from those areas. They planned to construct barriers and support farmers who'd lost crops during this time as well. So that was the Somerset Action Plan, regional action plan there. And then locally, what did we do? Well, we got 90 million to protect homes and businesses, and they spent this on flood walls and embankments, protect 350 homes and 32 businesses around Port Clarence as well, and areas in Stockton and Skinning Grove got shared out between them. Now, the flood defences were made by the Wilton firm, so employed local people as well, multiplier effect. And they have temporary flood barriers for industry along the River Tees who needed access to the river so they could kind of get in and out and shut them when they need to. So they tried to make it as appropriate as possible. So there we go. Those are our sort of defences and our responses that sort of went in place as a result of those. There are obviously other events that you can talk about. Beast from the East is one, but we mentioned windstorms earlier. Now, windstorms, there is little evidence, according to the Met Office, that climate change is affecting wind strengths across the UK. So, no compelling trends in storminess when considering maximum gust speeds over the last 40 years. Is human-induced climate change affecting the intensity of windstorms? Well, they're arguing not, okay? It can, at the moment, be linked to human-induced warming. Is the frequency intensity of windstorms expected to change in future? The UK CP18 found an increase in surface wind speeds in sort of the last sort of 50 years for the winter season. However, that's modest when compared to the natural variability year on year. So we are seeing a little bit of a trend, but it's no way correlation yet at all. Not enough to say that is the case. There's more frequent or intense windstorms. And that's because the North Atlantic Oscillation, the NAO, is one of the most important influences of winter climate across Northern Europe. And they do think the Intergovernmental Panel on Climate Change does think that oscillation is becoming slightly changed, and that's going to favour milder, wetter, windier winters across the UK. but that's still nothing compared to the natural variability that we're sort of seeing at the moment. So yes, there is a slight trend linking this to the carbon sort of cycle, but nothing concrete in terms of our area at the moment with this. But we are still seeing more frequent flooding events. We're seeing more extreme windstorms and, you know, events such as Beast from the East back in 2018, what we just saw here. And you can use your GCSE case studies as another example should you need to for this. So that's the UK as a hazardous environment.